Welcome to the video portion on conditionals. Now, conditionals are extremely important. They're heart of gaming, and they're used constantly in paper vision. And there's two types of conditionals I use. One's an if statement, and the other is a switch case. Now, in this particular case, you might say, well, what does this have anything to do with a conditional? And this is a simulation that I built in paper vision. And it is running kind of slow, but it gives you the opportunity to see what's happening here. There's different types of stars that are circling the Earth here. As you see them pass, you may not be able to see it real well in this particular simulation, but they're not the same. There's a little starry one. There's kind of a circular one. A little later, you'll see a few more starry or cubed or boxes or circular stars pass by. I think we have several stars in here randomly selected from a switch case. And that was done basically using conditionals like a switch case I just mentioned. Here's a nice funky looking one coming by right here. So you're basically, I'm going to show you how this is built and done. We'll do some simple examples with the if statement, and I'll show you a real life example where we actually take Papervision's particle system and add a bunch of different possible particles using a switch case. So let's get on to it. Conditionals are really easy to create in ActionScript 3. Here I've started an if conditional. Here I have an if and a parenthesis and open and closing curly brackets. And so I want to have a statement in there. Let's just go ahead and create a variable. I'll go variable my x, for example. We'll let that equal a number, and we'll say it's equal to 5. And let's just put a condition in here. If my x is equal to 5, and use a double equal sign when using a conditional, then just trace something out. Trace. Let's say it was equal to 5. Alright. And that should go to the output window, so let's go and run the code and see what happens. And if you look at the output window, it says, hey, it was equal to 5. So that worked. And so let's just expand upon this a little bit. As I said, this is easy, but you may not have seen conditionals before, so it's your first time. Now let's say it's not equal to 5. Let's say that it's equal to 6. And so we want to do something when it doesn't happen or when that condition is not met. So we actually create what's called an else statement. So we'll put else on the end of this. And open that up a little bit. And let's trace something here. So I'll copy and paste this code right here. And you'll find that easy to copy and paste code. I encourage that tremendously. We'll paste that here. I'm not doing a very good job of lining everything up as far as formatting code is. I'm terrible at that. And so it was, we'll put not equal to 5. And so let's run the code now and see what happens. And it was not equal to 5. So that works. So what happens here is that our variable is 5. And it says if x is equal to 6, what's not equal to 5, then go to else and trace out it was not equal to 5. Now, you may have several conditions, and if you do that, you can use an else if statement. So we're going to do else if. And we could actually do a little parenthesis here. Excuse me. There you go. Else if, let's say my x is equal to 5 down here. Or else if, paste that in. Now we can use equals or we can use greater than, less than signs as well. So else if x is less than 6, and we're going to say it was less than 6. There you go. And then we can put another else statement on the end of that. Else, we'll put a trace statement here. Doesn't meet conditions. Okay, so I mean, you can see how that goes real quick, right? So let's run this and see what happens. File, we'll save that, and we'll control test it. We got a syntax error. Let's go fix that. Doesn't like something here. And of course I haven't put this in this trace statement. That's what's wrong right there. So this has to be put in curly brackets. and this needs to go into a trace statement. There we go. And it looks like I put an extra else in there, so let's take that out. There we go. And that should be pretty happy with that. So let's save that and run it. And it was less than 6. So if we come along here and we do one more thing and we pull it out of the home realm and let that equal to 7, it should say it doesn't meet conditions. So let's control test that. And I see I have an extra E in my meet. Take that out. Let's save it. File, save, and control test. Doesn't meet conditions. So what it's actually doing in this code is pretty much it's a hierarchical conditional. It's going, and that's very important where the switch statement is not. It's going, well, if this is true or not true, if it's true, do it. If not, go to the next one, and then go to the next one. And you can actually concatenate these else-if statements. You could actually put 100 of these and have 100 conditions. But you don't want to do that. You actually want to use the switch statement. So we're going to actually go to our notes, look at a few things, and then take a look at some Papervision code. So here's a few notes on conditionals which you'll find useful as you do your work in Papervision. The if statement can contain a number of parameters. It can be an equal sign, a not equal by using the apostrophe equal, a greater than, a less than, a greater than or equal to, or less than and equal to condition. It also works well with Booleans, so if something's true or false, your condition can be fired as well. We already looked at the if statement, and the one thing I want to say is when you're using if statements, you can also concatenate using the double sign here for an and, or sign here for or. So here's an example. If fish equals tuna and sheep equals lamp, then trace I am hungry. So just a real simple conditional, kind of funny. And we looked at the else if statement. Here's the form for the else if statement. And then we looked at the and since the else if again, and showing that you can concatenate several of those at once. Let's come along here now and actually take a look at a Papervision example. Papervision has a particle system. In its particle system, it actually uses the else if statement. It has a circle shape and it has a square shape. So if you put a certain parameter in here, and if your shape is equal to a square, you run the graphics that creates a square. And if your shape is equal to a circle, you run the graphics that's equal to a circle. And there's only actually 2 graphics, and if you're making a star system, that's kind of boring. So what we want to do is actually create, in a sense, another scenario. So you want to go through a number of items and select one, and there's 2 ways to do that. You can use a concatenation of else-if statements as shown in these code below here, or you can use a switch case. So let's take a look at the switch case real quick. I'll bring up Flash over here. So here's our switch case scenario, and it's really beautiful. You just have the switch, and within that you can have a number or a string, and depending on whatever the value is of that number or string, you just select the case that agrees with this. For example, if you had a 2 here, you'd go to case 2, and you'd execute some code inside the switch case, and when you're done you hit the break statement, which takes you out of the switch. Now, as I mentioned earlier, we're going to actually create a bunch of particles that we're going to turn into different types of stars. And you might wonder why we don't just use a bunch of concatenated else-if statements. Why should we use a switch statement to do that with? And the problem is, as you're using else-if statements, it has to test each condition. So you're actually using more CPU, where within a switch statement, here's an example that I pulled from the appendix of the book, is that you actually choose the number. So in a switch case, you have a switch with a number, and whatever that case is, as far as the number is concerned, then you go directly to that case and you select it. So you're not actually essentially going through every single case to get to a final case, thus wasting precious CPU memory. Let's go ahead and see how this is done. So we're actually in Papervision's particle material class, and as I shown earlier, here's that else if statement, which allows me to select a square or a circle. But we want to add more particles. We're going to do that using a switch case. So I've actually already done that, and here's my switch case scenario. And what we see here is we have the switch case right here, and so you just put your shape type in here, and if it's a square, it chooses square, circle, star, and I have lots of different elements that can be chosen. Shape of a gear, and some of these are very complicated functions to create. Here's a wedge, and here's a break, and here's a shape poly, and it just keeps going on. Here's a shape burst, and here's a default. So if it's not in there, it says, hey, hit default and break out of the switch case. So in each case, it's more efficient because I don't have to go through each case and test it. I just select the one according to my switch statement. So that's why it's a switch case. Here's a switch, whatever it is, go to that case. So you'll find this more efficient. It's what you're going to want to use as your systems become more complicated. However, for simple systems, if and else if are sufficient. But once you get above 2 or 3 particles, I immediately just switch to the switch case. Let's go ahead and run the code and take a look and see what happens. And there's my many particles being selected by my switch case randomly in the code, and they're scrolling across the scene. Now we'll get more into this as we move on in the chapter in paper vision, but essentially that's a nutshell, and you'll see a lot more of switch case as you learn more about flash and flax.